This is what happened to all the water on Mars. Mars is now a chilly desert. Nevertheless, dried up riverbanks and deltas show where water formerly flowed over the planet's surface. But where did everything go? In an effort to comprehend why Mars turned into a dry wasteland, while its neighbour, Earth, managed to retain its water and develop into a biodiverse paradise, scientists have been attempting to find an answer to this topic for decades. Today, a group of geologists and atmospheric scientists has developed a new theory of Mars's history by incorporating observations of the red planet into fresh models. It's possible that a large portion of the planet's prehistoric water was trapped in the crust's minerals, where it is still present today. Watch this video to the end to find out what happened to all the water on Mars. According to earlier studies, Mars's atmosphere was being worn away by the sun's radiation, which caused the majority of its water to escape into space. But this new research, which was digitally presented at the Lunar and Planetary Science Conference this year and was published in the journal Science, comes to the conclusion that Mars's water underwent both an atmospheric exodus and a geologic confinement. The new model suggests that between 30 and 99% of the water was absorbed into minerals in the planet's crust, with the remaining portion escaping into space, depending on how much water there was to begin with. The truth lies somewhere in there, according to Brian E. Horgan, a planetary scientist at Purdue University, who was not part of the current research since it is a wide range, and both processes probably had an impact. The tale of the planet's youth has to be completely rewritten if the new model is true. The planet had far more surface water in its early years than earlier models had predicted, and that early period may have been considerably more hospitable to microbial life than previously assumed. All of the water, thought to be locked in the Martian crust today, indicates this. Draining to desiccating. It's obvious that Mars formerly had a lot of water on its surface from the many dried-up riverbeds, deltas, lake basins, and inland seas that are visible today. While there is a great deal of disagreement, it may have even had one or more seas in its northern hemisphere. The majority of Mars's water is now trapped in the polar caps or in ice that is buried under the surface, with the exception of what may be a number of salty subsurface lakes and aquifers. Scientists have been able to estimate how much surface water, as ice, liquid water or water vapour, would have been present at different points throughout Mars's history by studying the chemistry of Martian meteorites of various ages and using NASA's Curiosity rover to study ancient rocks and measure the current Martian atmosphere. They believe that if all of that water were liquid now, it might have once covered the whole globe in a shallow ocean that was between 150 and 800 feet deep. When Mars's atmosphere was thicker and greater pressure was present, liquid water could exist on the surface. Nevertheless, research utilising NASA's MAVEN satellite revealed that the solar wind-charged particles flowing from the Sun may have stripped away a significant portion of the planet's atmosphere as soon as 500 million years after Mars originated. The exact causes are unknown, but it's likely that the planet's early loss of its protective magnetic field was a major factor. In any case, Mars became a desiccated wasteland as a result of this atmospheric annihilation, which evaporated almost 90% of the planet's surface water. This water vapour was then broken apart by UV light. Hints concealed in Martian jewellery. Based on the sorts of hydrogen found in Mars's current atmosphere, the fate of the planet's primordial water has previously been hypothesised. UV rays from the sun bombarding airborne water vapour cause hydrogen to be taken away from oxygen containing water molecules. Free hydrogen is a light gas, thus it may quickly escape into space. Yet, some of the water vapour includes deuterium, a heavier form of hydrogen that is more likely to stay in the atmosphere. The quantity of deuterium left behind may be used to calculate the amount of the lighter form that was formerly present on the planet, as scientists are aware of the natural ratio of hydrogen and deuterium that should exist on Mars. Deuterium therefore serves as a spectral fingerprint that indicates how much water has already been lost to space. Scientists can calculate how much water is permanently lost from Mars by measuring the rate at which hydrogen is escaping from the planet. According to lead author of the new research, Eva Lingen-Scheller, a doctorate student at Caltech, if this pace had remained constant throughout the previous 4.5 billion years, it would not even come close to explaining the loss of such a large amount of surface water. All the orbiters and rovers studying the rocks on Mars provided another piece of information. Many water-bearing minerals, including several clays, have been found during the previous 20 years. Initially, only isolated patches were discovered, but according to Horgan, we detect evidence for a tremendous amount of hydrated minerals on the surface. The abundance of ancient hydrated minerals indicates that substantially more water than the atmospheric deuterium signal suggested was once moving over the ancient Martian soil. It's taken a long time to identify all the hydrated mineral exposures that we have identified, and then to properly appreciate their relevance on a global scale, observes Rice University planetary scientist Kristen Seeback, who wasn't involved in the research. 2 ways to the destruction of a planet. According to Scheller, one issue was that earlier models failed to appropriately account for the crust's capacity to store water within minerals. She and her co-workers made the decision to develop a new model to determine the location of Mars's water throughout the course of the planet's 4.5 billion year history. The model involves various assumptions, including how much water Mars originally possessed, how much was subsequently brought by the planet to watery asteroids and frozen comets, how much was lost to space through time, and how much more water was added to the planet's surface by volcanic activity. The scientists discovered that Mars may have previously had enough surface water to form an ocean that ranged in depth from 330 to 4,900 feet, depending on the values of those factors. Surface water dramatically declined between 4.1 and 3.7 billion years ago due to absorption by crustal minerals and escape into space. According to Scheller, no hydrated minerals have been discovered that are more recent than 3 billion years, suggesting that Mars has spent the majority of its existence as a dry wasteland. The new model has its limitations, and several crucial features are still unclear. While not a part of the new work, planetary scientist Geronimo Villanueva of NASA's Goddard Space Flight Center in Greenbelt, Maryland, believes it is a significant step that will undoubtedly support many future inquiries regarding the history of water on Mars. For starters, it aids in resolving a difference between the estimated water content provided by the deuterium measurements and the many water features still visible on the surface. It wasn't apparent how so many rivers and lakes could grow from so little water, Seeback adds. But this new model gives a solution to that riddle by locating extra water that may have been present on Mars. The amount of water that scientists now believe to be accessible on Mars, which is very little, remains unchanged despite the discovery. Horgan speculates that astronauts may one day roast hydrated minerals on Mars to release their water, but that procedure would be energy intensive. According to this analysis, Mars was the most hospitable in its early past when there was more water to play with, claims Seeback. If microbes had existed, they may have spread across all that water, but by the time most of it evaporated 3 billion years ago, they would have had trouble surviving. According to Byrne of North Carolina State University, the hypothesis that a significant amount of water may disappear through the crust has ramifications for other rocky planets as well. Minerals on Earth may bond to water as well, yet plate tectonics on our planet recycles these minerals, continually releasing their water via volcanic eruptions, according to Seebeck. Mars, on the other hand, may have been destined to become a ferociously frigid desert because of its stationary crust. Did Venus experience the same global transformation as Earth? Can water get trapped in exoplanets outside of our solar system? The model lays the door for an even fuller understanding of how Mars and other rocky planets change through time, according to Scott King, a planetary scientist at Virginia Tech who wasn't involved in the study. The question of what happened to all the water on Mars is one that may never be fully answered. But one thing is clear. The discovery of water on Mars has opened up a whole new world of possibilities for exploration and discovery. With new missions planned to explore the planet's surface and search for signs of life, we may soon have the answers we have been searching for. In the end, the mystery of Mars's missing water only adds to the intrigue of this fascinating planet. Who knows what other secrets Mars is hiding, just waiting to be discovered? The possibilities are endless, and the excitement is palpable. The question remains, what will we find when we finally unlock the secrets of the Red Planet? Like this video and subscribe to this channel for more exploring videos like this.